Hey everyone, in today's video what we're going to do is solve the limit as n goes to infinity of n multiplied by the square root of n multiplied by 2n choose n divided by 1 plus n multiplied by 4 raised to the nth power. Now to solve this problem what we're going to do is rewrite the factorials using Stirling's approximation, and then it's just essentially cancelling all of the common terms. But before we do that, let's recall how we can rewrite 2n choose n in terms of factorials. We have n choose k is equal to n factorial divided by k factorial multiplied by n minus k factorial. So in our case, we have 2n choose n, so we would have 2n factorial divided by n factorial squared. You can verify this yourself. Now, recall Stirling's approximation. Stirling's approximation says that we can approximate n factorial as n divided by e raised to the first power, all raised to n, multiplied by the square root of 2 pi n. So we have 2n factorial divided by n factorial squared. Beginning with n factorial squared, all we need to do is square everything in this formula. Doing that, we have n factorial squared is approximately n divided by e raised to the first power raised to 2n multiplied by 2 pi n. Now, in order to use Stirling's approximation for 2n factorial, what we're going to do is rewrite n as 2n and substitute that into the formula. Doing that, we have 2n factorial is approximately 2n divided by e raised to the first power, all raised to 2n, multiplied by the square root of 4 pi n. Let's rewrite our limit in terms of all of this. We have the limit as n goes to infinity of n times the square root of n multiplied by the square root of 4 pi n multiplied by 2n divided by e raised to the first power, all raised to 2n, divided by 1 plus n multiplied by 2 pi n multiplied by 4 raised to n multiplied by n divided by e raised to the first power, all raised to 2n. So certainly a bit of a mouthful and quite a complicated expression. But essentially all we need to do is be careful and cancel out the right terms. But first, let's rewrite this as three fractions being multiplied together, and let's just try to group things that are a little bit more similar. So we have the limit as n goes to infinity of n divided by n multiplied by 1 plus n multiplied by the square root of n multiplied by the square root of 4 pi n divided by 2 pi multiplied by 2n raised to 2n multiplied by e raised to 2n divided by n raised to 2n times e raised to 2n multiplied by 4 raised to n. So what we're going to do is just cancel terms in each of these fractions separately. The first one's pretty straightforward, so I'll leave that to you. Beginning with the second fraction, notice that we can rewrite the square root of 4 pi n as the square root of n multiplied by the square root of 4 multiplied by the square root of pi. Now the square root of n times the square root of n is just n, and the square root of 4 is 2, and that cancels with the 2 in the denominator, and the square root of pi divided by pi is just 1 over the square root of pi, because we would have 1/2 minus 1, so we would have minus 1/2, and then we would bring that down into the denominator to make it positive again. So that's the second fraction taken care of. Let's move on to the third one. Now, cancelling the e raised to 2n with the e raised to 2n in the denominator is straightforward. If we distribute the 2n to the 2 and the n, we have 2 raised to 2n times n raised to 2n divided by n raised to 2n multiplied by 4n. We can cancel these n raised to 2n with each other, so we're left with 2 raised to 2n divided by 4n. Now, notice that we can actually rewrite the numerator as 2 squared, all raised to n. 2 squared is just 4. So this is actually equal to the denominator, and we're just left with 1. So as you can see, this limit's really just a case of cancelling terms very carefully. So let's substitute this into our limit above, and upon doing so, we will see that we have 1 divided by the square root of pi, and we can bring that out because it doesn't depend on n, multiplied by the limit as n goes to infinity of n divided by 1 plus n. Now, what do you notice about this limit? Well, it's actually of indeterminate form, infinity over infinity, and that means we can solve it using L'Hopital's rule. So if we take the derivative of the numerator and the denominator, we see that they're both just 1, and the limit as n goes to infinity of 1 is just 1, because there's no n in it, so it's not affected by the limit symbol. Thus, we get our final answer of 1 divided by the square root of pi. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe? If you have any questions, make sure you leave them in the comment section below. And if you see someone's question that you think you might be able to answer, make sure you give it a shot. I hope you have a great day.